MathKlik.
Mabuhay! A complete quadratic equation in standard form is easily solved when its left side is factorable. What if the quadratic part is not factorable? How do we solve non-factorable quadratic equation? How do we solve quadratic equations? By completing the square. In this lesson, we will talk about solving quadratic equations by completing the square. In the previous video, we talked about solving complete quadratic equations of the form ax squared plus bx plus c is equal to 0 by factoring. We used the discriminant d to determine if the quadratic trinomial is factorable or not. The required value for d for the quadratic trinomial to be factorable is a perfect square value. The problem arises if d is not a perfect square, which implies that ax squared plus bx plus c is not factorable. For instance, in testing whether we can solve the quadratic equation x squared plus 6x plus 7 is equal to 0 by factoring, we compute for the value of d. Since d is equal to 8, which is not a perfect square, the equation x squared plus 6x plus 7 is equal to 0 cannot be solved by factoring. But good thing, we have a different method that we can use to solve a quadratic equation that cannot be solved by factoring. One such method is called completing the square method. The key skill in using this method is producing a perfect square trinomial, or PST for short. Let's investigate some quadratic PSTs and later see how we can use our observation in using the completing the square method. In the PST x squared plus 4x plus 4, the constant term 4 is equal to the square of 1/2 times the coefficient of the linear term 4. In the PST x squared minus 8x plus 16, the constant term 16 is equal to the square of 1/2 times the coefficient of the linear term negative 8. In the PST x squared plus 14x plus 49, the constant term 49 is equal to the square of 1/2 times the coefficient of the linear term 14. And in the PST x squared minus 18x plus 81, the constant term 81 is equal to the square of 1/2 times the coefficient of the linear term negative 18. Note that in any PST, the constant term can be obtained by squaring 1/2 the coefficient of the linear term x. Moreover, these relationships between the linear coefficient and the constant term work only when the leading coefficient or the coefficient of the quadratic term is 1. Now, let's practice producing a perfect square trinomial. What constant term must be added to x squared plus 6x to produce a perfect square trinomial? To answer this, first, identify the value of the linear coefficient b. Next, take 1/2 the coefficient of b. Then, square whatever result we get. Hence, to make x squared plus 6x a PST, simply add 9. For a clear demonstration of completing the square method, let's use a previously solved quadratic equation by factoring. The left side of the equation x squared plus 2x minus 63 is equal to 0 is factorable. Let's isolate the constant term by mentally adding 63 to both sides of the equation. The result is x squared plus 2x is equal to 63. Mentally compute for 1/2 the coefficient of the linear term. Then square it. Add this value to both sides of the equation. In doing so, a PST is produced. Factor this PST and at the same time simplify the right side. This yields quantity x plus 1 squared is equal to 64. Extract the square root of both sides, which results to x plus 1 is equal to plus or minus 8. Then solve for the values of x. Therefore, the roots of x squared plus 2x minus 63 is equal to 0 are 7 and negative 9, which affirmed our previous solutions. Let's take another example. This time, let's solve a quadratic equation involving trinomial that is not factorable. Solve the equation x squared minus 3x minus 1 is equal to 0. The left side of the equation is not factorable. First, isolate the constant term 1 so that x squared minus 3x is equal to 1. Try to mentally compute for 1/2 the coefficient of x, which is negative 3, then square it. The result is 9/4. Add 9/4 to both sides of the equation. This expression is a PST. Factor the resulting PST x squared minus 3x plus 9/4 and at the same time find the sum of 1 and 9/4. The result would be quantity x minus 3/2 squared is equal to 13/4. Then, get the square root of both sides. And finally, solve for x. Therefore, the roots of x squared minus 3x minus 1 is equal to 0 are 3 plus square root of 13 all over 2 and 3 minus square root of 13 all over 2. If you have difficulty solving a factorable quadratic equation by factoring because of so many possible combinations of numbers to choose from, you may find the method of completing the square much easier. Take a look at this example. Solve the equation 4x squared minus 5x minus 6 is equal to 0. Note that the coefficient of the quadratic term is not 1, it's 4. First, we divide both sides by 4. This operation will make the coefficient of the quadratic term 1 and gives an equivalent quadratic equation x squared minus 5x over 4 minus 6 over 4 is equal to 0. Isolate the constant term to the right side by mentally adding 6/4 to both sides. That gives the equation x squared minus 5/4 x is equal to 6/4. Make the right side a PST by adding the square of 1/2 of negative 5/4. That means adding 25 over 64 to both sides. Factor the PST on the left and combine the fractions on the right. Apply the square root property. Finally, solve for the values of x. Hence, the roots of 4x squared minus 5x minus 6 is equal to 0 are 2 and negative 3/4. This validates our previous solution to the same equation solved by factoring. Now, try this. Solve the equation x squared minus x minus 12 is equal to 0 using the method of completing the square. The solutions are x is equal to -3 or x is equal to 4. Solve the equation x squared minus 2x minus 1 is equal to 0 using the method of completing the square. The solutions are x is equal to 1 plus square root of 2 or x is equal to 1 minus square root of 2. For more matitinik tips, just click MathKlik. And please, don't forget to subscribe and click the notification bell for our next video lesson. See ya!